Hello, my name is Jacob Rausch, and I am the head of development at SQE. And for those that are unfamiliar, and to provide some context, SQE's technology eliminates the need for the use of the traditional public key encryption. Instead of exchanging keys over the internet, which could be compromised by a quantum computer in the near future, we use a fundamentally different approach that is quantum resistant. At SQE, we have created a network that allows for all registered devices through the use of our SQE hardware or software to reference our SQE time base, which creates a network-wide synchronization. This gives the ability to all synchronized devices, like the three that you see on the screen, the ability to already know how to encrypt and decrypt packets without the need to send an encryption key over the internet. Today I'm going to be walking through and demonstrating to you guys how our time base works, what components make up our time base, and how we can leverage different devices like the three you see on the screen to encrypt and decrypt packets on a quantum proof level. So let's begin. As you can see, we have three different devices here and represented on three different windows. What we see here is we have our SQE Genesis on the left. The job of the SQE Genesis is to authorize the creation of every other device, whether that's real or virtual. In the middle is our SQE node. The job of the SQE node is to create the blocks on the SQE blockchain, and it runs our SQE smart contracts. The device on the right is our SQE link. The job of the SQE link is to secure our communication by deciphering our 1024-bit SQID. The links decipher an SQID, which unlocks the encrypted information that is pertained to that entity. An entity could be a user, a company, or an organization, a user's assets. It could be an item that a user owns, such as a bicycle, or it could be the three devices that you see on the screen, which are each represented by a unique 1024-bit SQID. Before we jump into the time base specifically, it is important to notice that each of these three devices are all in sync with each other through the use of their space particle and time particle, as well as they all have the same timestamp. We'll take a deeper look into the time base now. So we can expand this window here, which is our SQE Genesis device for this example. And what you can see highlighted in the blue is our timestamp. Our timestamp is universal. Every device is using it as a reference to whether they are too fast or too slow based on the incoming and outgoing communications that it's performing with the rest of the SQE network. Associated with the timestamp is our time particle. Our time particle is represented by a 1024-bit number. Right now, we're just displaying the lower 32 bits. And from that time particle, we have our space particle that's associated with the time particle. We have many space particles. Our space particle is used for our communication, and we have many different types depending on the entity and the functionality that the entity will be performing. For example, a link device communicating to another link device has its own space particle to use for communication. The use of these space particles can also be further leveraged to create an onion-like structure for encrypted private transmissions. For example, a point-to-point device sending a private transmission to another point-to-point device will be encrypted with multiple space particles to expose certain data to certain entities. This would allow the SQE backend to route the transmission to the receiving device, but it prevents the SQE backend to being able to decrypt the entire packet, which means the SQE backend in this example does not have access to the device's communication. This idea of an onion layered structure can be applied to not just communication between two devices, but for instance, secure messaging between two or multiple users. It also adds another level of complexity to our encrypted packets, further making it quantum proof. The uses of being synchronized with using the SQE time base, the use of very large numbers, and the fact that no space particle is used more than once in any communication allows for private transmissions going through the SQE network to be quantum proof and unhackable. It is important as a whole to describe the foundations of our time base as a whole, our system takes it a step further. It doesn't rely on an if statement to determine when a moment in time has occurred. Instead, the time base evolves naturally based on the flow of data itself. These printed values represent observed time. Before they're computed, time exists in the kind of unresolved state, similar to quantum superposition, where its exact value isn't determined yet, but once observed, it becomes a concrete timestamp. We use the observed time as the foundation of our encryption. And this leads into the question, how can we apply the time base you see in front of you using the three columns or the three values represented within that time base, the time stamp, the time particle, and the space particle, to encrypt and decrypt packets. As stated earlier, ultimately our encryption algorithm uses the space particle to encrypt data. Our algorithm performs bitwise encryption, where each data bit is encrypted using a corresponding key bit. This one-to-one mapping enables precise control over the encryption process and enhances resistance to certain quantum and classical attacks. For example, a 1 megabyte file will require 8 million bits of encryption. However, we have a minimum packet size of 8,000 bits of encryption. So if a user is sending just a hi to another user, that transmission will still require 8,000 bits of encryption. And that wraps up my demonstration for you today, taking you through our time base, demonstrating different devices in different locations, synchronizing, and how we can use this methodology to transmit quantum secure messages through the internet without the need for a public key. Again, my name is Jacob Rausch with SQE, and if you are interested in learning more, check out our website at sqe.io and be on the lookout for more videos and demonstrations coming soon to show you what we are working on at SQE.